recorder. Okay, so for the turn on the mic. So for the first part of the class, I just want to kind of mention this particular movie. I think it really is interesting to watch this movie. Not so much about the drama part and whatnot, but it kind of explains how computers came to be the state that we have today. It also kind of highlights how much computers have improved over time. I think that will be one of the focus that we can one of the things we can focus on with this movie. Because if you think about a war movie, okay, because it is a war, it's not exactly a war movie, but the background is the end of, close to the end of World War II. So you see bombers, you see fighter airplanes, tanks and whatnot. And then you can compare those to modern day tanks, okay? An old tank, from the 1940s to a tank that we have today. Yeah, the tanks today are much better. Okay, the fire control mechanism are much better. The gas and the diesel engines are much better, but are they that much better? Okay, so what do you mean? What do I mean by that much better? We'll talk about that later. You see the bombers, right? Propeller planes, okay, fighter airplanes and stuff like that, and you compare those to what we have today, and you say, well, the ones that we have today are much better. They're supersonic, they have stealth technology, they have guided missile, and da 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 da. Okay, great. Okay, they're much better today. And then you look at radar technology, okay, which was actually invented in World War II out of necessity, and you compare radars to the radars that we have today, and yes, the ones that we have today are much better. And then you look at the computer, okay, and you go like, wow, that's not even recognizable, right? When you look at a tank from 1940s and you compare to a modern tank, they still have about the same shape, the same design, the treads, the cannon, the engines and whatnot, right? But when you look at a computer, quote unquote computer in this movie, and you compare it to your cell phone, there's no resemblance whatsoever, okay? So I think that really is one interesting aspect of this movie, is it reminds us, how things have progressed over the past 50 years. This is the one technology that has seen a lot of progress, much more so than any other technology that I can think of. Okay, so I'm going to give you a little preview. Okay, I'm just going to play one of the previews here so that you have an idea of what the movie is about. And let's do it in HD, why not? We got the bandwidth. And it's not, that's my mic. Oh. It's not, okay, maybe the output is not.
It's a silent film.
It's not a silent movie. Then you will see a pause, screen pause, and then the text, right, the captioning. Yeah, that's not what it is. Let's check the output. That's the speaker. Okay, I think the preview is over. That's the one that is in use, but the volume is all the way down, so let's try that again. There we go.
Is anything possible? No. It takes me ages. This isn't about crossword puzzles, it's about how one approaches solving an impossible problem. To tackle the whole thing at once or divide it into small problems. You finished?
Yes.
5 minutes and 34 seconds.
You said to do it in under 6.
Okay, that scene is about the interviewing and screening of people to do the decoding by hand. Okay, because before they invented the computer, the decoding was actually done by hand because it was still doable by hand. And Alan Turing basically said gave the people instruction and said you have to do it in under 6 minutes, and then he said that it took him 8 minutes. So he was expecting the candidates to do it in 6 minutes, and then this woman was able to do it in 5 minutes and something. So so she became a part of the team. I think this is another clip. The Imitation Game. It's about Alan Turing, the father of computer science.
This war, we're not winning it. If you speak a word of what I'm about to show you, you will be executed for high treason.
It's beautiful. It's the greatest encryption device in history, and the Germans use it for all communications.
Everyone thinks Enigma is unbreakable.
Let me try, and we'll know for sure.
Mr. Turing, do you know how many died because of it?
I don't.
3, while we've been having this conversation.
Gentlemen, meet Mr. Turing. We to work together then. I'm afraid these men would only slow me down.
Popular at school, way?
We're short on staff. We get more staff then. You have 6 minutes to complete the task.
Is it even possible?
No, it takes me 8. 5 minutes and 34 seconds.
You said to do it in under 6. What is it that we're really doing?
We're going to break an unbreakable Nazi code and win the war.
Oh.
You know, to pull off this irascible genius routine, one actually has to be a genius.
I'm designing a machine that will allow us to break every message, every day, instantly.
You're going to need all the help you can get, and they are not going to help you if they do not like you.
Have you decrypted a single German message?
You will
Never understand the importance of what I am creating here. Our patience has expired.
No!
If you fire Alan, well then you'll have to fire me.
Me too.
And me.
You better bloody well.
Alan, you do not have to do this alone.
What are you doing? What's going on?
The Navy thinks that one of us is a Soviet spy.
You've got more secrets than the best of them.
What if I don't fancy her in that way?
Can't tell anyone, no. It's illegal.
I'm just a mathematician.
Sometimes it is the people who no one imagines anything of who do the things that no one can imagine.
The name Imitation Game is also interesting because the other name of, well, the other way to refer to the imitation game is called the Turing test. The Turing test is basically his way, Alan Turing's way of qualifying whether a computer has intelligence. Because the way it is done is you put a computer in a different room, and it will communicate with an actual person using a teletype, device, okay, a dumb terminal, if you will. And in the conversation using, that dumb terminal device, if a person is convinced the other side is actually a person, then the computer passes the test of being able to imitate a human being. So that is also known as the Turing test, which is actually kind of interesting because back in those days, computers do not even nearly have the processing power to do something like that. And the guy came up with ideas of how to test a computer for intelligence. Okay, is this computer quote unquote intelligent? And that's basically the Turing test. Since you're in this class, many of you will probably take a class at a 4-year university called either computation theory, automata theory, or something along that line. Formal language is the other title. Those are all things that he invented, that he came up with, and they still stand. Okay, even though technology itself has moved so far ahead from the 1940s, the mathematical theory behind computers really has not changed. It really has not changed much since those days. So I think that's why I really want you guys to kind of at least know about this movie. If you're not going to watch it, that's fine. But I want you to know about this movie because according to many people, this is as close as they get when it comes to actually showing what happened in that time. The other ones would be a PBS. I think they have one whole section, one whole episode on the Enigma machine and how encryption and decryption work at the end of World War II. So it's good to reflect on how we got to this point, and also to appreciate all the changes that have happened in the past 50, 60 years when it comes to technology, even though the underlying theory really has not changed. If you look at physics from 50 or 60 years ago, that has changed quite a bit. Okay, even physics has changed because they have new discoveries, new particles and whatnot. But computer science actually has not moved forward much when it comes to the actual theory. The programming languages, yes, okay, we have a lot of stuff that we have changed in the past 5 years. When you look at versions of iPhones, even more, right? I mean, iPhones come with new versions faster than C and C++ come up with a new standard, much faster. But when you look at the more underlying math and all the theory, the formal stuff, it really has not changed much. And this guy, basically, came up with all of that stuff in the 50s. So that's why I think it's kind of significant for a class like this. All right. So with that one out of the way, I'm going to talk about the exam. This one is exam 1, so I can pass it back to you guys. It has been in my bag since like quite a few weeks ago, but for this particular class no one asked me about it, so I always forgot to pass it back to you. So it's good to reduce the weight of my bag a little bit. So when you guys are doing that, I'm going to talk about the answer of the current test, okay, the one that you guys just took. So we'll go ahead and talk about the answers. The grading is going to take a little bit longer because I'm still in the process of making photocopies of the test. And having some of the exam stable on the other side did not help because I forgot that I stapled on the wrong side. So I fed one of the exams into the scanner, which has an auto feeder, without remembering that it was still stapled, and that did not work out very well. All right, so let's take a look at the previous exam, and I can answer questions that you might have for that one. So the first one is, I will show you the program first, okay? I'll show you the program, and then we'll answer the question. There we go. Okay, so this is the first question. The first question uses standard I/O. It's kind of almost the same as the original first question, except it has a little twist in it. Int x, int counter. So these are pretty much the same thing. Counter equals to 0, while counter is less than 5. Char ch scanf %c and %ch. If y++ equals to 0, then we increment counter here. All right, and then we just have a simple return 0 at the end of the program. Let me just double check, make sure that this is the actual code. I just want to make sure I don't miss anything. Oh, there's an initialization of y here. So we have int y gets initialized to 0. Oh, we have a double loop. Sorry about that. What about the double loop? While not scan f %d %x equals to 1. Okay, there we go. That makes more sense. All right, I think that is the That's the one that you have in the exam. All right, double checking. All right, so this is exactly the one, you know, on the test. There we go. Okay, so the question is, indicate whether this program will exit at all or not. Okay, that's the first question. So that is really just yes or no. This program will exit or this program will not exit. Some people came to me and asked for clarification, like, you know, okay, but exit using what input? And my answer to that was, you can determine what what you want to put into standard input, and make this program exit. So the real question is it possible for this code to exit if you have full control over what is in standard input file? That really is the question. So what do you think? Can we get out of this loop here? Can we get out of the outer loop and also the inner loop? The answer is yes, okay? So that means, you know, counter can be made so that it is no longer less than 5. But in order for counter not to be less than 5, the only way to increment is over here. So the question is, can we get to this statement 5 times so that counter becomes 5 and then the outer loop would exit? That really is the question. So we have to look back and say, okay, but how do we get here? We get here if y plus plus equals to 0. Now, when y plus plus equals to 0, what is it telling you about the value of y before line 17? Has to be 0 before, right? Because y plus plus is post increment, which means the expression has the value of y before adding 1 to it, and then the side effect of the expression is to increment the value of y. So that means y has to be a 0 before this. And when does y get a value of 0? All the way here on line 12. So when we get here, if there's a chance that we get to this statement here, at least the first time we get here, because it is also in a loop, the first time we get here, y definitely has a value of 0. Okay, that much we know for sure. So the next question is, can we get here at all? Can we get to line 15? In order to get to line 15, this statement has to be true. And what will make this statement true? The first one is an exclamation point, which is a negation, which means we want the other part of the expression to be false in order to make the entire expression true. So this is the part that we want to be false. How do we make scanf %d %x return something other than 1?
Enter a char.
Give it something other than a number, right? Okay, so if you present anything other than a number, or can be the beginning of a number in standard input file, this condition becomes false. When this condition becomes false, then the overall expression with the negation becomes true. Then we'll get into this part here. So once again, it is dependent on whether we are presenting something that cannot be interpreted as a number to the program. But this one is different from the one before because it is guarded. Okay, the increment of counter is no longer standing by itself, but now it is inside a conditional statement. The conditional statement is saying if y plus plus equals 0, which means if y originally has a value of 0, then we'll go ahead and increment counter. But after the first time, because of the post increment operation, y has a value of 1. So in subsequent iterations of this loop here, we will never increase counter again. It will take us all the way out to the outer loop in order to reinitialize y to 0. But in order to get to the outer loop, this has to read an actual number in order to get out of the loop. Does that make any sense? So that means the test code of the original program would not work anymore. You cannot give it A, B, C, D, E, and then a 0 to make it work, because the original code will work, because A, B, C, D, E, each character will cause counter to increment exactly once. But in this case, the A will make it increment, but B, C, D, E would not do anything to counter, because by that time y is already non-zero and it's not going to increment it. Okay, so what we need to do is to give it a non-number like A, and then a number which is like 0, a non-number like A again, and then the 0, A0, A0. So we have to interleave 5 times in order for counter to increment exactly 5 times, then it will exit the outer loop. Is that okay? All right, so let's go ahead and test the code, okay? So instead of just talking about it, let's go ahead and actually run the code here. So we'll do a -G in case we want to get into GDB, -O Q1 Q1.C, and then we'll run Q1. So we need 5 actual numbers in order for this to work. So A0, 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 A0. So that would be 5 numbers, and then it exits. Okay. Now what if I give it something just 1 character less, fewer than the previous one, A0, 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 A, without the last 0? It's not going to exit because it needs that 1 more integer to get out of the outer loop. Okay, thank you. All right, so are there any questions about this particular question? Okay, so the second part of the question, of question 1, is asking, otherwise, make an input that will make this program exit. The input should be just enough to make this program exit, which means if it lacks 1 character, the program will not exit. Okay, that's what I'm looking for. So that means if someone gives me A0, 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 and 20 times of those things, that answer is definitely not going to get the full credit because it does not meet this requirement of I need the least amount of input to exit out of this program. Are there any questions? No questions? Did you do okay with this particular question? No? Yes? Maybe? Okay. I just wanted to show you the program one last time. So the trick is, this one here, okay? The conditional statement here and the initialization of the counter y is the addition to what you saw in the practice test question number 1. And that dramatically changed, what you need to do to get the program to exit, how to get counter to count up to 5. Are there any questions about how to analyze this program to figure out, how to get it out, to get out of the loop? No questions? Okay. Well, you can, if you have any questions about the earlier question, you can always, ask me again, during the middle of the class. But for now, we'll go ahead and move on to question number 2. So this is question number 2. Question number 2 is also based on the question number 2 of the practice exam, but it is also a little bit different. And this one involves a loop, whereas in the practice exam, it did not have a loop. But it is still trying to ask the same kind of question about scoping. So we have int j, I equals to 2, j equals to I plus 1, while j is greater than 0. We have int, we have another scope here. Okay, so this is the one has an extra scope, int j, and then we say j gets j I plus 1. CD out, C out, and the reason why we have the double scope is out of this inner scope, I do a j minus minus, and then we have a return 0 down here. So the question is asking what is the output of this program, and I gave you some blank space. Okay, so the way I presented the blank space is like this. So, because each time it prints, it will print 2 numbers. It will print first the I value, and it will print the j value with a comma in between. And that's why I gave you a whole bunch of lines looking like that, just so that you can just write the value and not worry about, oh, where do I put a comma? It's already here. All right. So let's go ahead and analyze this program, especially which I or which j am I referring to on which line. On line 2, we have a global variable I. Excuse me. And then you look into the main function. On line 5, we have a local variable j. So we have a global I and a local j by the time we get to line 6. Line 6 is referring to global variable I. Line 7 is referring to local variable j. So local variable j is going to have a value of 3 because it is 2 plus 1. So now we get to line 8. Line 8 is referring to this j and say, is j, which now has a value of 3, is it greater than 0? Yes, it is. Then we move into the loop. We go into line 10, which opens up another scope, and it has now another local variable j. This local variable j on line 11 is going to hide the j of line 5. So this j starts off with an unknown value. Okay, it has a value, but we don't know what it is. It may or may not be 3. And then we do the initialization here, and I at this point still has a value of 2. So this particular j, the second j, the j that is declared on line 11, now has a value of 3. So this will print 2 because I as a global variable has a value of 2, and j, referring to this j here, which is 2 plus 1, also has a value of 3. And then we get out of this inner scope here. When we get out of the scope from line 10 to line 15, this j is now referring to which j?
Line 13.
The j that we declared on line 5. Well, that's the declaration. This is where we initialize it. So this is the j that refers to the j that was declared on line 5. It had a value of 3. Now it is 2. Okay, and we get back to the beginning of this loop here. This j is referring to the same j, which has a value of 2 right now. 2 is greater than 0. We get in here. We have another j which has nothing to do with the first one, the one that was declared on line 5. And once again, we initialize this j to I plus 1. Did I change the value of I? No, I still has a value of 2, right? So this j will continue to be initialized to a value of 3. So by the time we print, it will print 2, 3 again. And we'll keep doing this. Okay, it's going to print 2, 3, 2, 3, 2, 3, 3 times, and then the program will exit. Okay, so it's not going to print 2, 3, 2, 2, 2, 1, 2, 0. It's just going to be 2, 3, 2, 3, 2, 3, and then the program exits. All right. So did you guys get this one? Okay. No. Okay.
Well, why would the program exit?
The program will exit because j eventually gets down to 0. Because the j that we use in the condition of line 8 is the same one that we use on line 16, and that is the one that we declared on line 5 and initialized on line 7. So that j, is going to start with 3, and then for each iteration of the loop, it will decrement by 1. So you can see that it will eventually decrement to 0, and then we get out of the loop. The trick of this one is line 11, the inner scope, which defines another local variable j on line 11. That j has absolutely nothing to do with the j that we declare on line 5. That really is the trick, of this particular question. And it is really testing, do we know the scope of this particular j? Well, it is inside, the scope of a variable is inside the open and the closed curly brace block statement. So this is the extent of the j that we declare on line 11. So when we're out of this block here, on line 16, on line 8, on line 7, and also on line 5, those are now referring to the j of the outer scope, they don't have anything to do with the inner scope j. Okay. Any questions on this one? Okay. And let's go ahead and test it, right? So G, CC, or G++, doesn't matter. Well, this one has to be G++ because it has a C in, C out. So dash G dash O, Q2, Q2.C. Oh.
Title Q2 to Q2.C.
Oh, okay. Thank you. I was wondering, it's like, how come it's not printing? Okay, so it does print 2, 3 exactly 3 times because this 3 refers to the inner scope j, which is not the one getting decremented. All right, question number 3. Okay, question number 3 is the one that asks you, it's the one that has recursion, and it's asking you what is n, what is the output of the program, and the program outputs, n equals to something, r equals to something. So let's go ahead and take a look at that one. Q3.cpp. Oh, that's the other Q3, so let's move this one out of the way. Okay, so here's the new Q3. Pound include IO stream int f int n. We have a local variable r, std out c out, n equals to the variable n, or the parameter n in this case, std n line. If n is greater than 2, we do something, otherwise we do something else. If it is greater than 2, we say r gets f of n minus 1, and then r plus equal to f of n minus 2. Otherwise, we say r equals to n, and then we do another c out here. But this time we're only reflecting what is r, or the result of the calculation. And then we return r as the return value. So that's the subroutine itself, and now we have main, which is really just an entry point of the entire program to test how this works out. So it's going to have its own std out, c out, f of 3, std n line, and return 0. Okay, so the question is asking what is the output of this program. Be sure to indicate n equals to or r equals to on each line, except for the last one. The last one does not actually have anything like that. The ordering of the lines is important, very important. Okay, in other words, you have to kind of make sure that you present the output in the correct order. All right, so let's go ahead and do it by hand. Okay, the easy way to answer this question, as far as my perspective is concerned, is easy, right? I just compile the program, run it, and show you the output, and I can just move on. But that won't explain why it is outputting the values that it is outputting, which kind of defeats the whole purpose. So what I'll do is I'm going to do this by hand. Okay, we'll do it line by line by hand, and hopefully that will show you, how recursion works. All right, so I'm going to use Notepad here or mousepad to show you how this program works. Execution starts on line 21. Okay, on line 21. There are a few things to do, but eventually I want to do some output. Okay, I want to output the value of f of 3, and then followed by the end of line. But can I do any output right now at this point? No. Why not?
F passes 3 to
I have to figure out what is f of 3, right? Okay, so line 21 is going to call function f. So this is going to call f with a parameter of 3. Is that making any sense? Okay. So as a result of that, we are getting into subroutine F. Now, in subroutine F, we are starting on line 5. So on line 5, in the subroutine F, okay, I should probably insert another line here. This is the first invocation of F, and whenever we invoke a subroutine, there's a new set of local variables and parameters. So R as a local variable starts to exist at this point for the first invocation of F. But since R is a local variable, it starts off with an unknown value. We know it exists at this point on line 5, but it has an unknown value. But on line 5, I don't really care about R because I just need to know what is n. So the output is going to be n equal to, and the value of n at that point is 3. That's the output from line 5. This is the first line of output. It says n equals to 3. And then where does it go? And then we go to line 6, right? Because line 6 just follows line 5. They're sequential. So on line 6, the condition is if n is greater than 2, then we do blah blah blah. Well, n is 3. 3 is greater than 2 is true. So where do we go next?
line
We go to line 8. Okay, so we go to line 8. And line 8 says, oh, you know what? We have to call f again, because before I can initialize r, I have to call f so that we can figure out what is f of n minus 1. So it's going to call f again. But this time when we call f, what is the n? What is the parameter to this particular invocation? The second one, 2. So n has a value of 2, and that will get us to the subroutine itself, right? That will get us back to line 5. So this time on line 5, which is the second invocation, r once again starts with some kind of unknown value, and we'll also that's not line 5. Line 5 is here, which is actually doing the output. So this time, we're going to output n equals to 2, because at this time, this is the second invocation with a parameter of 2. And after line 5, we get to line 6. Line 6 is asking, is n greater than 2? Well, n is 2. 2 is greater than 2 is false. So we are not going to go for line 8 this time. We go for the else, which is on line 13. So line 13 says r gets n. So there's no recursion at this point. So we now say, r gets n, and which is 2. Then we get out of the conditional statement. We get to line 15. Line 15 has something to output to. Line 15 is going to say r equals the value of r. So the output is r gets 2, or r is 2. And then we get to line 16. Line 16 is going to say, oh, okay, I guess r is the return value. So we are returning the value of r, which is 2. So we are actually effectively returning 2. Then where did we go? We go back to line 8, okay? We came from line 8. Now, how do I know we came from line 8? You look at this entire invocation here. Who called it? We called it on line 8, okay? So we get back onto line 8, and what else do you think line 8 has to do? The assignment, right? We use the return value to update variable r. So, okay, well that's not too hard. So r of the first invocation now gets the return value of the second invocation of f. So r has a value of 2 at this point. Then we move on to line 9. Line 9 says, you're not done yet. We're going to have to call f again, okay? So line 9 is going to call f again. But this time, what is the value of the parameter?
0.
1, okay? Because when we get to line 9, it says it'll invoke f again, but this time use the parameter of n minus 1, n minus 2. Which n are we referring to? The n that has a value of 3, right? So 3 minus 2 is 1. So now we call f with a value of 1. And the execution path is pretty much the same as the one before. So whenever you call a subroutine, the local variables start to exist for that invocation. And then we start execution on line 5 again. So on line 5, it's going to print the value of n. So n is 1 at this point. Then we get to line 6, which is the beginning of the conditional statement. N has a value of 1. 1 is greater than 2 is false. So we are going to the else branch, which is on line 13. Line 13 is going to say the r of the third invocation of f is going to be the same as the n, which is 1. Then we get out of the conditional statement, we get to line 15. On line 15, it's going to print r is the value of r, which is 1. That's what it's going to print. Then we get to line 16. Line 16 returns the value of r as the value of the invocation of the subroutine. So we are actually returning a value of 1. Then where do we go back to? Who called us?
9.
Line 9, exactly. So we get back onto line 9. And what else do we have to do on line 9?
Add 1.
We're adding 1 to the value of r. So r gets 2 plus 1, which is now 3. Then we proceed after line 9. Line 9 is the end of the then branch of the conditional statement. So now we get out of the conditional statement. Continue execution on line 15. Line 15 is going to print the value of r. So the output is exactly just r equals to 3. Then we get to line 16. Line 16 is returning the value of r, which is returning 3. And then where did we get back to? Who called us?
21.
Line 21. So we get back onto line 21. And at this point, we have something to print on line 21. So line 21 is going to print 3 itself and the line feed character, which I don't really show here. But if you want to imagine, it's that. Okay, it's the \n. And that concludes the execution of the program. So the output, if you collectively look at the output, is going to be n equals 3, n equals 2, r equals 2, n equals 1, r equals 1, and r equals 3, and then just 3. Excuse me. So that should be the output of the program. Let's go ahead and check it. That's the exactly the output that we were expecting. Are we okay with this one? Because this one is recursive, and it has to do with how do you keep track of the execution. Excuse me. So it has to do with how you keep track of the execution of the program, and also at the same time keep track of whose n and whose r are we referring to. So using a different column, each time you invoke, really kind of helps, because it visually shows you that we are dealing with this invocation as opposed to an earlier invocation of the same subroutine. Any questions about this one? Okay. So that's question number 3. And this one does have partial credit, because the output has several lines, so each line has its own partial credit. Okay, we're moving on to question number 4. Question number 4 is similar to question number 4 of the exam, of the practice exam. So let me copy the current Q4 to Q4 practice.cpp, and I can give you the actual one in the test. Okay, so how include IO3 int x and main void int x equals 2 std cout x fine, and then return 0. There we go. Okay, so the question is, does this program contain an error or warning at compile time? It was very specific, only at compile time. And the answer, so you can either say yes or no. What do you think? The answer is nope, has no problem. This code is fine because specifically it's only asking about compile time. If I ask you about runtime, if I ask you about link time, there can be all sorts of problems happening at link time, because I can have another file that redefines X or redefines main or do any of those things. But if it's only at compile time, everything is okay. The compiler has no problem with this code at all. Okay, just to be sure. So we say G++ dash code Q4.cpp, which also does the linking too, but it definitely will go through the compiling, and neither the linking or the compiling gives us any problem in this case. Any questions about this one? Yep.
So you said it is a warning, not an error?
A warning is not an error. So if you say there's a warning, what type of warning are we talking about?
Use an initial aspect that you use.
Say again?
Your initial aspect that you use, that's one warning.
No, it is used because it is used in the printing. Okay, let's check it. Dash warn all, pedantic, and there's no warning. There's no warning because this is considered a use. When you read something, it is considered a use, and this is the initialization. So X is actually used in this program. If you say it is a warning, I'm not going to take any points off, because the question asks various. Oh, it is asking whether it contains an error or warning at compile time. Okay. It does not actually have a warning, So I will have to find out how to give partial credit. Yep.
But I tried. Remember, we were going over with the extern question in class, and I kind of stuck up on that. So I typed the code in the code blocks, it actually gave me error while compiling, whilst in the Linux environment it didn't.
What type of error message did it give you? Do you remember in code blocks?
Not really, but if I'll run it, it's something. It's either initialized or something else with that.
Okay, let's take a look at the one in the practice test and see how it is different from this one. This is the one from the practice test.
Yes.
And it gave you a warning or an error?
An error? I'll compile it right now here.
Are you sure it is a compile time error and not a link time error? Because it can be a link time error. If you compile, okay, let me give you this one. So I will compile and link a Q4P instead of Q4, and this is the error that we get. Is this kind of what you saw? Undefined reference to X.
Mm-hmm.
That's a link time error. It's not a compile time error.
Oh, okay.
Right. And that's exactly because when you look at the one from the practice test, extern is basically saying assume. It is basically saying, it's telling the compiler and say, don't worry who defines X. Assume it is already there. The linker will take care of it. So the compiler is going to say, okay, if you say somebody is going to define X, and I can just rest assured that X will be there, I'm not going to complain. So the compiler is not complaining. But when you're linking the program with only Q4P itself, then we have a problem because nobody is actually defining the variable, okay? We only have one piece of code assuming the existence of X and make use of X, but nobody's actually defining or creating the variable X. So that's why the linker is going to complain about it. Now, to make this even more clear, what we'll do is we'll separate the compiling and the linking into two steps and then see which step actually causes complaints about this process. So the first one is the compiling, and the compiling is the only part where the warning actually makes any sense because the linker does not give you warnings. Pedantic -C is the one to turn on, just compile, do not link to the program. So this is q4p.cpp, and you can see the compiler does not complain. Now, when you link it, you specify the -O option to specify the executable name and say that I'm not compiling anymore. Let's go ahead and link the object file so that it becomes an executable file. This is the second step. This is the linking step. And you can see that the linking step is the one that is complaining. This is yet another reason not to use code blocks because code blocks combine the compiling and the linking into one, and it is not clear whether it's complaining about the compiling part or the linking part.
Can you go back to the test?
Yep. Which one?
No,
the test question.
Yes.
Okay.
So initial the X outside the main, which is made of the global X, right? So
No, this is actually referring to the local X.
No, on the top.
On the top here?
Line number 2.
Yeah. This is defining global variable X. So it makes X start to exist. The global variable X starts to exist.
Okay.
But I'm not even using it here because I have a local variable X here. So the X on line 6 is referring to the X that we declare on line 5.
That's why I mean line X wasn't even using the parameter.
Oh, as a global variable.
Yeah.
The global variable itself?
Yes. So give the warning on that then?
It does not give you a warning on the global variables. Now, the reason why it does not complain about global variable is because this program may not be the only component. So there can be other component that has an extern int X that actually make use of X. So the compiler cannot just look at this program and complain and go like, you define X and you're not using it for anything. Let me give you a warning message. It cannot do that because it cannot legitimately do that because other files, other source files can refer to the same global variable X, and the compiler has no visibility of the other source, potentially other source files. Yep.
So the compiler is just going to assume that the global variable X is going to be somewhere else?
Because the compiler knows that global variable X has a global scope. Not only global scope within this source file, but within all source files of the same project. And knowing that, the compiler cannot say, based on what I can see in this particular source file, that the global variable x is not being used, because it can be used by another source file that has an external int x at the beginning.
Well, I know that C++ is different than VB, but in VB, if you declared it and didn't use it, it would give us a warning.
But that's because in VB, everything is in one single file. By parsing and analyzing that one single source file, VB has a complete picture of the entire program. But in C++, we can break up a program into multiple source files. The compiler works on the source file basis, so when it look at only one single source file, it has no idea whether a global variable is actually being used or not in another source file, and that's why it cannot complain about it. The context, does not allow the compiler to know that this is not a good use of the global variable. The linker, on the other hand, can probably complain about it, but it does not. There was another hand. Yep.
I pretty much just assumed that we wouldn't be able to look at other files or it would reference other files. So I was just like, hey, you have an extra global variable here that's not used. That's a warning from my perspective.
I'm not good. I think what I'll do is I'm not going to take points off if you explain the warning is about a variable is declared but not used or initialized but not used. So that I'm not going to take points off.
If you said it's an error, then you would.
No, what I'm looking for is people who do not understand the scope and complain about, oh, x is defined again. That is what I'm looking for, or that will basically be a sure thing of not getting any points, is to misunderstand and say that, well, we have a local variable x here, so the compiler will complain and say you're redefining x. That will be the problem. But if you think, if you just write down and say the compiler may warn about, x being defined but not used, I'm not going to take any points out. Is that reasonable? Okay. All right. So that's question number 4. We are moving on to question number 5, and it carries equal weights too. So this one actually has the same weight as the recursion program, which I think kind of helps because that one is a little bit more challenging, takes more time. This one is kind of like yes, no. Okay, question number 5 is recursion again. This one is kind of long, so I'm not sure whether I should type it up or not. But I know from scanning the answers, quite a few people got it right. So several people actually figure out what it does, which is actually pretty impressive. So I'll go ahead and type it anyway. I can type and explain at the same time, so we'll go ahead and do that. Q5P. Oh, that's CBP. Go. But this one is kind of interesting. Oh, that's a copy instead of a move. Okay, include IO stream, and then once again we have a recursive subroutine that returns a character. So in this particular subroutine, it has a local variable char or ch. If standard in, standard cin reading into ch is successful, then we do something, otherwise we do something else. If it is successful, we'll check what ch is. So if ch is a comma, then we'll do nothing. Else, if ch is a question mark, oops, we'll also do nothing. Else, if it is not a comma and is not a question mark, then we'll do something. So what we'll do in this case is we have a TMP variable here, and TMP is kind of like just a temporary variable because I cannot use it right away. I cannot ch the return value of f right away, so I have to store it into a local variable first, and then we say std cout ch here, and ch is temp at the end here, and then the else part has, oh, there's no else part because there's nothing to do for the else. and then we just return ch. So that's the entire subroutine for f. So you can see that f has a recursive nature to it, because on line 19, f is being called from itself. Now in main, excuse me. In main, we have a do loop, do while loop. So while ch does not equal to question mark, and then return 0 at the end. And then inside the loop, we have just ch gets f, or the invocation, the return value of f, and std cout ch, like that. Okay, so that's the entire program. Didn't take me too long to type it while explaining it too. And then the test input in question is AB, comma, C, and then the question mark. That is the test input. Several people came to me and asked me, is the question mark a part of the input? That's a very smart thing to do, is to double check and make sure that the question mark is not just a question mark as in, oh, okay, give me the output of this code. It is actually a part of the input. Okay. All right. So when you trace this code, it's a little bit challenging. It's challenging because I use all the empty lines here. That makes it a little bit harder. It's longer than it needs to be from the text perspective. So what I'll do is I'm going to change the font a little bit so that I can at least show the entire program when we work on it. So we go to appearance, change the font size to, let's say, 15, and see whether that's good enough. Close. Okay, maybe 14. I think 14 will do it. There we go. Okay, so 14 will do it. I mean, we're still, I think I can miss the first two lines, which is just the entry point of f. So we can start with line 5 here. Okay, so let's figure out what this program is going to do. This is the input. So the standard input is going to be just A, B, comma, C, and then the question mark. All right. So we'll start execution from the main subroutine, and in the main subroutine, execution starts on line 34. Line 34 is going to call f, okay? Because we don't know what to store into ch until we know what f is returning. When we call f, f is also going to create its local variables. So in this case, it will automatically create variable ch. Temp is not really technically created at this point because it won't be created until we get to line 18. Okay, so now we continue execution in the subroutine starting on line 6. Line 6 is reading one character into ch, right? So which character am I reading first? A. Okay, so ch gets a value of 8. So if you want to represent it on in a piece in a program like this, you can just say ch gets the character of A, okay, because that's what's going to happen is we are reading A from standard input into ch. After line 6, okay, after line 6, where do we go? Do you think C in right shift into ch is going to give us a true value or false value? It's going to be a true value because we did read a character. Okay, the read was successful, so it returns true. So if it does return true, we go to line 8. Line 8 has its own condition to evaluate, and it is checking whether ch is a comma. Is it a comma?
No.
No. So we go to the else case. So we go to the else case. We execute on line 13. On line 13, it asks, is it a question mark?
No.
Nope. Okay, so we move forward again to line 18. So on line 18 is where we actually have TMP as a local variable created, because local variables they start to exist when we enter the scope and they cease to exist when we get out of the scope. So TMP is actually created when we get to line 18. On line 19, it's going to call f again. So we're going to call f again, and execution goes from the beginning, goes back all the way back to the beginning of line of function f again. So that means now we have a local variable ch again, and we continue execution on line 6. Line 6 is once again try to read the character into ch. Which character am I reading this time? B. Okay, so ch. This particular ch gets the character of b, and the rest is kind of boring, right? Because we have the same stuff, pretty much the same path. Because the b is not a comma, so on line 8 the condition is false. Then we jump to line 13. On line 13, we are comparing to question mark. The letter B is not a question mark, so once again the condition is false. Then we continue on to line 18. Okay, so when we get to line 18, we are going to call f again, because line 18 is not the one that calls. Line 19 is the one that calls. So line 19 is going to call f again, and now we continue execution at the beginning of f again with its own local variable ch. Now this is kind of important because at this point we are on the third invocation of f, and you can see that each invocation has its own local variable ch. They do not overlap, they do not overwrite each other, they are not even related at all. Alright, so now we continue execution starting on line 6. Now this time on line 6, what am I reading into the third ch? A comma. So this time, when we get to line 8, the condition is true. And if the condition is true on line 8, we go to line 9 and line 10 and go like, oh, there's nothing to do. Great. Then where do we go? We go all the way to line 25. On line 25, this is all we're going to return. So we are only returning the character, the comma, as a character. And where do we go back to after line 25? Who called me? So we go back to line 19 and we finish the unfinished business on line 19. So what else do we have to do on line 19? Temp gets its value, right? Temp gets a value of what? A comma. Yep, that's it. And then on line 20 doesn't really do much. It is just going to do some output here. So I'm just going to use this to indicate that we are outputting the character of a comma. Whoop, wait, hold on a second here. It's not outputting a comma, it's outputting what? ch, right? And ch at this point has a value of what? B, that's right. Yep.
Isn't after line 19 you have to go back to line 6 again?
Sorry, say again?
Don't you have to go back to line 6 to column F?
We just did. So this is the first time we get to line 19.
Oh.
We call f. When f returns with a comma, we got back onto line 19 to finish what we did not finish the first time, which is the changing or the update of temp. So that's why this time we are not going to line 6, because we just came back from the function call. So it outputs B, and then there's one more thing we have to do on line 21. Line 21 is just saying, okay, ch is now tmp, but since tmp or temp has a comma, now ch has a comma. Is that okay? And after line 21, we get, so this is line 21 here. After this, we get out of the else branch of the inner conditional statement, which is also going out of the else branch of the outer conditional statement. So we end up on line 25 after line 21. And on line 25, we return whatever ch has. So we return a comma in this case. So now the question is, where are we going back to? Who called me? Line 19, exactly, because you can see that this entire column here comes from this one call. So we are going back to line 19 to finish the unfinished business of line 19. So what do we do on line 19? We change temp, right? This is the return value, the comma is the return value, and we're going to use that to update the temp here. Then we move on to line 20. Line 20 doesn't do much, it just prints whatever ch has. But what is the value of ch? A, the letter A. So we do a cout of A here. And after line 20, we go to line 21. Line 21 is just reassigning ch so that it is now the comma, because it's taking the value of temp and store that into ch. And then after that, we get to line 25. Line 25 is a return statement. It returns whatever the value of ch is, and that really is just the comma, the character of the comma. And then where do we go back to? This is getting a little hard to track. It was called from line 34, right? So now we get back to line 34, and what do you think line 34 is going to do? Not yet. Yep, it has to store the ch first. So ch gets whatever f is returning, which is the comma, and then 35, line 35 is going to c out it. So we have c out of a comma, and then that's the end of the loop. So we get to line 37. Line 37 is asking, do we stay in the loop? Because if ch is not a question mark, we stay in the loop. Should we stay in the loop or not?
Yes.
Yes, because we have a comma which is not a question mark. So we stay in the loop, which means we go back to line 34 and basically go back and do the whole thing again. Okay, this is going to take a little bit of time, and I would assign partial credit for this one definitely. Okay, so if someone can get to at least this part here and print B, A, and a comma, that would worth at least half of the credit, if not more. Well, probably about half, because knowing that when you see the question mark, it terminates, is also an important step. So that one is actually kind of important too. So, but there would definitely be partial credit, because if someone runs out of time and say, okay, I can only get to this part here, I would say each character output has a partial credit to it. So if someone can just print B and A and then at that point stop, there will still be some partial credit. Just printing B all by itself will have some partial credit too, because knowing is not printing A first is significant. Okay, so just having B and say, I don't know what the rest of the program is going to do, I don't have enough time to finish it, is already going to have some partial credit. But BA is going to obviously have more partial credit. BA and the comma, definitely more than that too. So are there any questions about number 5? This is question number 5.
The rest of the answer?
The rest of the answer? The actual output is going to be BA, a comma, a C, and then a question mark. That is the actual output. It reverses everything between the commas, and it uses a question mark to terminate. Yep.
What if I put a comma between the B and the A?
Then it would be partially correct and partially incorrect, because in that case, your the reason that you would be,
3 out of 5.
Yeah, because it has to do with line 18, 19, and 20. Because you're basically tracking the wrong one or using the wrong one to print, using the wrong order. Yep. There will still be partial credit. As long as you put the B ahead of the A, and understand that the comma is important, because it's not reversing everything. Okay, if someone gives me the answer of C, comma, and then B and an A, that would not worth as many points, because it doesn't. That trace does not show me that that person understands that the comma basically stopped the recursion and we are rolling back. But if you only do the B and the A and the C is not involved in the process, that means you still know when to stop the recursion and start to work your way back to the beginning. So that would still be kind of important. But it's not going to be as many points as B, A, and a comma. So I can see my rubric is going to be a little bit lengthy with this one. It's like, okay, for each possible case, there's how many points and so on. All right, any questions about number 5? No questions? All right, number 6 then. Number 6 is asking you to write some code to implement post increment. Okay. Okay, so let's get out of this one. Q6. We have some code here. So it is related to the Q6 or question 6 of the practice test. It's just not directly related, but it is definitely related because it has to do with pass by reference. Okay, so let's move the original Q6 to Q6p.cpp and then look at the one that we have in our test. Okay, so in the test, I have include stdio.h post increment int x here. And you're supposed to fill in some code here. Then we have the main subroutine. Int x, int y, x equals to 0, y equals to post increment x, and return 0. Okay. So right here, I have comment that says it should act the same as y gets x plus plus. Okay, so that part is important because I want the implementation of post inc to be exactly the same thing as x plus plus. Okay, now x plus plus has two things that you have to pay attention to. One is the value of the expression itself. The other one is what it is doing to x. So you have to imitate both of those things in your implementation of post increment. Okay. All right. So let's go ahead and see how we can do this. Now in the instruction, it also says right here, fix this program and finish post inc. So there are distinctly two actions that I'm describing. The first one is fix this program, and the second one is to finish post inc. Okay, so why would I separate it into two different steps? The way it is right now, do you think post inc can do anything to x? No, because it is passed by value. Okay, so when you're passing by something by value, you can do whatever you want with the parameter, but it does not change whatever you use to pass. It doesn't change the argument itself. Okay, so that means the first thing you have to do is to quote-unquote fix the program, is to change x so it is passed by reference. That is the first step. The second step is to finish or complete the program by writing the actual code of post increment. It also says right here, okay, solutions using the actual post increment operator will not get any points, which means if someone is smart and say, you know what, I'm going to do this, that won't get any points because I explicitly exclude the use of the post increment operator. Is that okay?
Yeah.
Okay, so I'm hoping that I make the instruction clear enough that no one is using this particular approach and say, oh, I'm just going to defer that and do it here. Okay, so if we cannot use the x plus plus operator, what are we going to do? Do you guys remember, I talked about the equivalent, comma separated, expression thing? Maybe we can do that here, right? So how does that go? Well, it goes like this, right? It goes like, x plus equal to 1 will be increment, or you can say x plus equal 1 is fine, okay? Or if you want to make sure that you're not using any operator that you're not supposed to use, this, okay? I cannot disallow that, right? And comma, and then just x minus 1. It should do exactly the same thing because what I'm doing here is I am adding 1 to x first, okay? But I'm not returning the value of x, the one that is after the increment. I am returning the value of x minus 1, which is the original value of x. And that's the expression, that's the value of the expression of x plus plus. Is that okay or not? No, not okay?
So if you were to print it, it's still incremented.
Huh?
Is it still incremented? Is it still incremented?
Yes, it is still incremented. Okay, the first part is the one that changes x. The second part does not change x at all. It's just referring to the value of x at that time. Subtract 1 from not x itself, but just the value of x, and evaluate the expression, and that becomes the return value.
Which one you actually returning, the x minus 1 or x plus 1?
It returns x minus 1. But that x in x minus 1 is after x gets x plus 1. Okay, there's another way to do this that's more clear. Okay, let's do it the other way that is more clear. The other way to do this, which is kind of more cumbersome, but at the same time it is also considered more clear, is to do it like this. Make a new variable temp, okay? Entirely new local variable, has nothing to do with x until now. Okay, so you say temp is x, which means temp is getting the initial value of x. This is before I do anything to x, right? Then the next thing we do is we add 1 to x. Okay, does the statement on line 6 do anything to temp? Nope, absolutely not, right? Because one is a parameter, one is a local variable, and they are completely independent. Then what are we going to return? Which one am I supposed to return? Temp. Yep. It will do the same thing. It's just that using the comma expression is kind of more concise, and also it still reflects what we need to do. This is a little bit more cumbersome because it involves the additional variable, but it does reflect the steps of what we need to do a little bit better. So both solutions will work. Okay, partial credit will be given. If someone forgets about the passing by referencing, that will lose some partial credit. But as long as the body of the subroutine is still correct, using the concise way or the long way, I don't really care. Each one will get the same amount of credit. So are there any questions about number 6? How many people spotted that you need to add a ampersand so that it's passed by reference? Okay, so that part is kind of important because otherwise, it's not going to change. It won't have the side effect of changing the variable that we are post-incrementing. But that's just a part of it. As I said, it's partial credit. All right. So now we are moving on to question number 7. We are running out of time. Question number 7 has 2 tasks. Finish subroutine inches to YFI, sorry, yard, feet, and inches. So I want you to do the conversion from inches to yards, and then to feet, and then to inches. I'm just going to go over that over here. So I won't finish the entire program. I just want to show you the code to do it. Okay, so that will make it D dot. Okay, which one should I work with first? Does it really matter? Well, it can matter. It depends on how you want to implement your program. Okay. Okay, so we'll deal with inches first. Okay, D dot inch is going to be inches, and then what do we do? When you express distance using yards, feet, and inches, what is the range of values for inches? No, 12 is not one of them. 0 to 11, exactly. It's from 0 to 11. Which operator can do this? Mod. Yep. So the first one is just that. What about feet? The number of feet that we have to deal with here. So this one is not as easy. Okay, it's not as easy because we don't want to deal with inches anymore. So we just want to deal with feet. So how many feet to 1 yard? 3. Somebody asked me during the test, and I just kind of pointed to the whiteboard. I wrote it on the whiteboard just so that make sure that everybody knows there are 3 feet to a yard. So in this case, what we need to do first is to divide all the inches by 12 first. When you do an integer division, it only keeps the quotient. So this will not give you a fractional part. It won't give you any fractional part. It will only give you the number of feet. Okay, we took care of the inches already in the previous statement. So this will give you the number of feet, but it will give you the number of feet for the entire distance. We don't want that. We want the number of feet to be 0, 1, or 2. Is that making any sense? Because we have a yard next to deal with the number of yards. So what do we need to do here? Do a mod 3, exactly. And then D dot yard is going to be what? Inches divided by 3 times 12 or 36. Yep, that will do it. Yep.
Could that possibly give you a problem because inches divided by 36 wouldn't necessarily be a whole number?
It's going to be the same issue as this one here.
Yeah.
Because integer division, the integer division, if inches is an integer and 36 is an integer, it will only give you the quotient of the division.
But if inches isn't a multiple of 36, it could be 37.
Then it will give you 1. Because 37 divided by 36 has a quotient of 1 and
So
a
it's only
remainder
going
of
to
1.
return the whole number value.
It
It's
will
only gonna
return-
give you the decimal after.
That is correct. It will only return the quotient, which is usually understood as a whole number. Yep. Did you do anything different? I mean,
Yeah, I was worried about the decimals, so I had subtraction of the fractional parts.
Oh, okay, I see. That would still be okay. You know, it's just that it's not necessary when we deal with integer division. Yeah, if it's a floating point number, then you will need to do that. Any other questions? So that's the solution of that particular question. And then the task 2 is, you know, what do we need in order to get 2 yards, 2 feet, and 5 inches? So that would be 2 times 36 to take care of the yards, plus 2 times 12 to take care of the feet, and 5 inch plus 5, you know, which takes care of the 5 inches. If you express it like that as an expression, you know, like 2 times 3 times 12 plus 2 times 12 plus 5, I would consider that a perfect answer too. Because the point is not to test your arithmetic skills, the point is to test, you know, whether you understand the question and be able to go through the calculations. And that's actually pretty easy. You know, you don't need to you don't need to take cisp360 to come up with the answer to that one. All right, so that's basically the whole test. So what do you think?
You can answer 110.
Huh?
You can answer 110.
Answer.
101.
Oh, is it 101? I never bothered to check. It's 2 times 36 plus 2 times 12 plus 5. So, yep, it is 101.
Yeah, probably that.
Okay. But remember, all questions carry equal weight. Okay? So if you get to the